Good morning everyone, welcome to integration class. Today we are going to study the last part of your integrations, and I hope till now we studied number of different forms and more than 300 problems in integrations. We started from the very scratch and we built a very big and strong foundation on calculus, and I'm sure we studied all variety of problems and we discussed variety of exercise, assignments, so many things throughout the class, and that made a big impact on your study in second PUC. I'm sure this foundation of calculus will help you to learn rest of your mathematics, especially definite integration, application of integration, as well as differential equations. And I'm sure this part of your calculus will lead you to be a good engineer in future. You're going to supposed to learn maths 1, maths 2, maths 3, maths 4, and even till your research, this foundation will make a big impact on your future careers. And the basics and the strong foundation will lead you to improve your speed and calculations of mathematics in all part of your day-to-day career. And even the most of the marks in competitive exams is based on this calculus part, and I'm sure everyone are now very perfect in basic foundation, and we're going to study different tricks and concepts in future classes. And this strong foundation on calculus will lead to the better understanding of physics, especially mechanics, electrostatic, electricity and magnetism. So all concepts what you have studied, mathematics part of calculus, will keep coming, and I'm sure the understanding of physics, you feel wow, or different perspective of physics you will get to know in rest of the classes. And let's start with the last form, that is form 15. So it is integration of root of a square minus x square dx, that is equal to x by 2 integration of a square minus x square plus a square by 2 sin inverse of x by a plus c. What are you supposed to do? How to do such kind of integrations? So in all such cases, we are supposed to consider this is a square minus x square into 1 dx. This is very important. This into 1, it will be same function, okay, but we have to consider this is 1 just because you should supposed to follow integration by parts. This is supposed by integration by parts. So to do integration by parts, there should be two functions. First function is root of a square minus x square into 1. Okay, now you apply the rule of integration, that is integration u dv equal to, or integration of uv dx equal to u into integration of v minus differentiation of u and integration of v dx. Am I right? This is what we studied in case of integration by parts. So same thing you apply here. I'll consider this is my first part, this is my second part. So this is lead to integration of root of a square minus x square into 1 dx, that is equal to first part as it is I am writing, that is a square minus x square into integration of 1 dx minus, so differentiation of first function that is a square minus x square into integration of 1 dx. Am I right? Into dx. Now keep on simplify, that is root of a square minus x square into 1 dx integration is x minus integration or differentiation of this will be 1 by 2 n into n minus 1, that is a square minus x square to the power 1 by 2, okay, into integration of inner function, that is minus 2x, it will be minus x square, differentiation is minus 2x, okay, into x dx. Now this 2 get cancelled with this 2, so left out is integration of a square minus x square into x minus 1 by root of a square minus x square. This minus I am taking outside, this is plus, so this will be x dx. Am I right? Now what you supposed to do is you are supposed to manipulate this part. I mean to say, so this will be equal to x into root of a square minus x square plus integration of, what I supposed to write is, I'll write is so this is x into x, this is x square, okay, and x square minus in bracket a square minus x square. See, now you see this is minus a square, okay, this is plus x square, so divided by a square minus x square. Now what happens, this will be 2x square minus a square, but here requirement is x square. What I do is, so I'll write it in a different way, that is a square minus x square minus x square. Is it now working? This will be minus 2x square. So instead of this, better you write x square minus x square a square minus a square minus x square. I think now it will work out. A square get cancelled, when you open the bracket this will become plus x square, so x square. So advantage is I can rewrite this as, so x root of a square minus x square plus, this looks like a minus b divided by c, am I right? So what I can write is a square, a by c, a square minus x square minus integration of, this is dx, a square minus x square divided by a square minus x square dx. This a square I can take outside and I can do the integration for this. Hope you are understanding what I am doing. I'll consider this as I, okay. Now I equal to, now this all I equal to, I'll tell you why I supposed to consider I. So because it is a repeating functions, wherever the repeating function comes you supposed to take it as I. First function is integration I. Now you see things will be keep repeating, especially this function root of a square minus x square. So this is equal to x root of a square minus x square plus a square into differentiation of root of a square minus x square. Here integration of a square minus x square divided by root of a square minus x square dx. Hope till now we are very clear with all the steps. Now if you observe, this looks like we know integration of under root 1 by under root of a square minus x square, okay. So this is a familiar function, am I right? I equal to x root of a square minus x square plus a square into integration of dx divided by root of a square minus x square minus, so this is a square minus x square in the numerator, denominator root of a square minus x square. If you take in the top, that will be 1 minus 1 by 2. That is again this part I could write like integration of a square minus x square dx. So function is keep repeating, okay. So now I equal to x root of a square minus x square plus a square. Integration of this will be sin inverse of x by a, am I right? Minus I consider this as I, okay. So I substitute same thing I. Now I minus, I will take this side, this will be 2i equal to x root of a square minus x square plus a square into sin inverse of x by a. If I take this side, I equal to x by 2 root of a square minus x square plus a square by 2 sin inverse of x by a plus c. This is what we supposed to derive. Hope you understood. Only thing is expand the given function, consider as I, then keep expand, consider this part, simplify and rewrite, and consider this as I, initial function, okay. Then take this 2i as something, then 2 take this side, and final answer will be this. So hope you are familiar with this kind of functions. Now we'll see one more form. This is out of form 15.1, first form. So we'll the second discuss. That time we will be familiar with the ideas and concepts. So one more form, that's out of form 15. One more form, that is integration of root of x square minus, previous one is a square minus x square, this is x square minus a square dx. That will be equal to x by 2 under root x square minus a square by 2. Previously it was plus a square by 2. Log of x plus root of x square plus a square, x square minus a square dx, okay. Sorry, not dx, plus c. So very careful, these two things you should remember. This will be same, okay. So first what you supposed to do is consider this as I and into 1. So this is most important thing, I equal to integration of root of x square minus k square into 1 dx, considering second function as 1, and apply the highlight rule and use integration by part simplification. That means, so integration of u into v equal to u into x square minus k square into 1 dx minus integration of differentiation of first function, that is x square minus a square into integration of 1 dx. Now root of x square minus a square, this is x, minus this will be 1 by 2 x square minus a square minus 1 by 2 into 2x. This 2 get cancelled with this, okay, into x, this whole into dx. This is integration of 1 is x. Now this will be equal to root of x into root of x square minus a square minus integration of this will be what happens, x divided by root of x square minus, this is to the power minus of, that you can write divided by root of 1 minus x square minus a square. X into x will be x square you should not miss this part. X into 2 get cancelled and x is remained. Again this is x from integration, so it is x square. Okay, now you supposed to manipulate this you keep as it is. This is I equal to this much, so x root of x square minus a square minus, so integration of what I can supposed to write is, so x square minus a square. If I do, is it work out? No. So you're supposed to think what better you can manipulate. So x square minus a square minus, so instead of this, because I want in the numerator x square, how we can retain? X square minus a square, so what I can write is x square minus x square minus a square. Now it will be plus a square, then it will be 2a square, so not working. So if I do minus on the other side, whether working, just think. So simple way is x square minus a square, I'll add a square. So now minus a square plus a square get cancelled, it will become x square. So divided by root of x square minus a square. Now this I equal to x root of x square minus a square minus, now this looks like a minus a plus b divided by c. So this divided by this plus this divided by this. So integration of x square minus a square divided by root of x square minus a square. This also become minus, am I right? So a square divided by root of x square minus a square. Over dx. Now this will be x root of x square minus a square. This I could write as minus, if I take in the numerator, this will be x square minus a square to the power minus half. This is 1. So simply you could say it is root of 1 minus half is half, that is x square minus a square dx minus a square I'll take outside. So dx divided by root of x square minus a square. Now this I equal to x root of x square minus a square minus, so this is a repeating function, root of x square minus, I can consider as this is I, okay. So I minus a square, this is a well-known function x square minus a square, so log of x plus root of x square minus a square plus c. Okay, now consider this I'll take this side, this will be 2i equal to x root of x square minus a square log of x plus root of x square minus a square. I'll take 2 this side, so that is x by 2 root of x square minus a square minus a square by 2 log of x plus root of x square minus a square plus c. So people might have confusion when I take this, this will be x by 2. Consider c by 2 equal to again constant, some constant, and rewrite this. Okay, so this is the expected result what we want. So only thing is, suppose you take this into 1, then follow the integration by parts method, simplify and manipulation this part very important, you have to a serious note, and you should remember 2-3 times you do yourself. You're supposed to follow this simple manipulation technique. We need x square, so what to do? Using the denominator and substitute as I, repeating functions, you repeat again I, you substitute and take I to the other side and simplify, so we'll get the expected result. This is how you're supposed to do the integration for these forms. Okay, hope you are familiar with this now. Last problem we'll see, last format, third form. So integration of root of x square plus a square dx equal to x by 2 root of x square plus a square. Previously it was minus, now it was plus. Very important, careful observation. Rest things will be same, x plus root of x square plus a square. Rest will be everything same, only here plus, this is plus, it is plus. Previously this is minus, here also minus. Rest as it is, same function it will follow. So somehow you interlink when you study and try to remember. That is most important. Remembering formula in maths is make a big effect on your competitive exams. Somehow you put effort, your 5 minutes efforts, daily efforts to remember the basic formula. Then understanding, concept matter to solve the variety complex problems. Now same concepts repeats. Consider this is I into root of integration of x square plus a square into 1 into dx. Now follow, this is first, this is second function. So it is root of x square plus a square integration of 1 dx minus integration of differentiation of the first function, that is x square plus a square into integration of 1 dx into dx. Now simplify, this is I equal to root of x square plus a square integration 1 dx is x minus differentiation of first function. We will get 1 by 2 root of x square minus a square to the power minus 1 by 2, okay, into x, sorry, integrate differentiation of inner function, that is x square, that is 2x into integration of 1 dx, that is x dx. Dx is the integration for this, okay, don't confuse this dx, this dx. So better you put a bracket, so you will clear now. Okay, now simplification. This is equal to x into root of x square plus a square minus this to get cancelled, integration of dx divided by root of x square plus a square into this we can x square dx you can write. Now this will be I equal to x into root of x square plus a square minus, again you have to manipulate. How do you manipulate? So integration of x square, so I want x square in the numerator, x square plus a square minus a square. So a square get cancelled, x square left in the numerator plus a square dx. Now I'll write this divided by this plus minus this divided by this. So x root of x square plus a square minus integration of x square plus a square dx divided by root of x square plus a square minus become plus integration of a square divided by root of x square plus a square. So this I could simplify and write x root of x square plus a square, okay, minus integration of root of x square plus a square. Hope you understand how this become this simple. This is to the power 1, this is half. When I take in the numerator it will minus half. So 1 minus 1 by 2, it will be 1 by 2. So that is root of x square. And this is a repeating function. plus a square into integration of dx divided by root of x square plus a square is dx. Now here I substitute I because repeating function. Okay, so I equal to x root of x square plus a square minus I plus a square. So integration this first is very famous, log of x plus c. Now I'll take this side, 2I equal to x root of x square plus a square into log x plus root of x square plus a square plus c. If I take 2 this side, my integration will be x by 2 root of x square plus a square plus a square by 2 log of x plus root of x square plus a square plus c. This is the required result what we can see in the top. This is how you're supposed to do. Very important things, writing as first function into second function as 1. Then rest of the things same as follows by the previous problem. And manipulation here, very important, you just observe this, and rewriting and substituting that repeating function as I, taking I to the other side, it will become 2I into something, I equal to the final answer. So remember this results, 3 results, so it will make a very big impact on the rest of the problems. So probably you'll get some complicated functions in competitive exams. So if you remember all the forms till 15, I'm sure it will be click on your mind. You'll get a pitch, you'll get a hold on integration. So okay, this is looks like this form, because we studied in very organized fashion. I'm sure if you follow all the forms, then your integration will be very so easy. You feel very happy and very smiley face during your exams, because we have created such a big impact by creating different forms and different categories of problems. Okay, when you see the problem, you feel like, okay, this belongs to these forms, so that it will strike on your mind. So if you are not practicing, my sincere request is please practice as per the forms, and you feel very comfortable for the rest of the chapters in mathematics. So we'll see few problems based on these forms, simple problems. First question we'll see, question number 1, integration of 9 minus x square dx. So I can rewrite this as integration of root of 3 square minus x square. Am I right? So just we have seen it looks like a root of a square minus x square. We know that. So I'll write this form so that you will be familiar with this. So what I suppose to write, x by 2 into a square minus, it is very easy. See, x by 2 into same function you are writing. Then you have a confusion, plus or minus. Okay, here minus is there, so this will be plus. Plus a square by 2 sin inverse of x by a plus c. So now if you apply this form here, a square minus x square, so first one is same, x by 2 root of 3 square, or I could write 9 minus x square plus a square, that is 9 by 2, a is 3, remember, sin inverse of x by 3 plus. Hope you are getting. Question number 2, integration of 1 minus root of 1 minus 4x square dx. Here coefficient of x square is 4, you are supposed to take out. When you take 4 out, what happens? It will be 2. So integration of 2 into 1 by 2 minus x square, or 1 by 4 minus x square dx. 2 I'll take outside, and this I could write as 1 by 2 whole square minus x square dx. Now resembles same form. So what I can write is 2 into x by 2 root of is 1 by 4 minus x square plus a here is 1 by 2. So a square is 1 by 4 by 2 into sin inverse of x by 1 by 2 plus a. Simplify. So what happens, this will be x, 2 get cancelled, root of 1 by 4 minus x square plus 1 by 8. 1 by 8 into 2, that will be 1 by 4 sin inverse of 2x plus c. This is the final answer. This is how you are supposed to do such kind of problems. So better you remember the form, so then things will be very easy. Hope you are getting the pitch. So one more problem we'll see. Question number 3, integration of root of 16 minus 9x square dx. Again, coefficient of x square is 9, take 9 outside. So this is 3 root 16 by 9 minus x square dx. This again you can write as 3 into integration of 4 by 3 whole square minus x square dx. Now resembles like this form. So simply you could write this is 3 into x by 2 root of a square, that is 16 by 9 minus x square plus a square is a is 4 by 3. So 16 by 9 by 2 sin inverse of x by 16 by 9 plus. Simplify, this will be 3x by 2 root of 16 by 9 minus x square under root plus, so 2 2s are 2 4s are, so it is 2 8s are, so it will be 8 by 9, 8 into 3 24, 24 by 9 sin inverse of this will be 9x by 16 plus c. This is the final answer. So if you remember the form, just substitution and simplifications. Okay, it will say 2 steps. If you made any mistakes in the sign of the form, the whole problem will go wrong. So very careful in the sign of the forms and formulas. Simplification, very careful when you take something outside, when you multiply, you should multiply to each form, because between algebraic sign is there, plus or minus, so you should be very careful. These are the small things. Most of the time in calculus, students do mistakes in very silly plus or minus, or they confuse with basic forms, so whether it is or basic equations, formulas, whether it is plus or minus. So if you put daily 5 minutes effort to remember the equations and formulas and forms, and it will make a big impact on your future careers. So please be ready. Stick on yourself to the list of formulas. First you make a list of different forms, different formulas, and put effort daily. Look into the forms, try to memorize yourself and utilize wherever it requires. So this is how you're supposed to do. If you put 1 week effort, I'm sure you are able to grasp everything, because you studied so much problems in the class, as well as you did exercise. I'm proud that you will definitely do, and you will get a pitch on integration. All the best. So we'll see a few more problems based on these forms, and we'll wind up with the integrations, basic integration done. So we'll see CET level, JEE Mains, JEE advanced problems slowly, one by one, so that you will get a familiarity on variety of problems in future. Thank you. Thank you.